as a very hot, dense, single point in space, which expanded from there and is continually expanding today. This is sort of a graphic of how astronomers believe the universe has expanded and grown, beginning from the Big Bang, which you can see on the left is a single point in time when time began and space appeared, and since then has expanded for 13.8 billion years to where we are now. Now, when the universe was very young, about 100th of a billion of a trillionth of a trillionth of a second, so an incredibly, incredibly short amount of time, it underwent an incredible growth spurt. And this was right after the Big Bang initially happened. So this was right at the beginning. During this burst of expansion, which is known as inflation, the universe grew exponentially and doubled in size at least 90 times. So the Big Bang, people call it an explosion, but I think people can get misled by the word explosion. It wasn't a physical explosion like when a bomb explodes, there's like a physical reaction, but it was sort of the appearance of space, like the matter and space came to exist at that point in time. And before that, there wasn't anything. That is the Big Bang theory. There are some other theories out there, but the most commonly believed one is the Big Bang theory, which assumes that before the Big Bang, there wasn't anything, and during the Big Bang, which they call the explosion, all of the space and matter appeared. Yes, the theory says that it just appeared. If we go, you can like look up the specifics of what astronomers believe like caused it, but a generalization is that it appeared. There are several different thoughts about what might have caused it, but we don't know specifically exactly what happened. So most scientists just generalize it as the appearance of space and the beginning of our time. So after the inflation phase, which was when the universe expanded a lot in a very short amount of time, the universe continued to grow and expand, but at a slower rate. And as space expanded, the universe cooled and matter formed. Now, for the first 380,000 years after the Big Bang, the intense heat from the universe's creation made it essentially too hot for light to shine because there was so much energy released during the Big Bang. So after that, about 40,000 years later, matter finally cooled enough and the universe expanded enough for electrons to combine with nuclei to form neutral atoms. This phase is known as recombination. The era of recombination was followed by a period of darkness before the stars and other bright objects were formed. This time period was called the Cosmic Dark Ages, which lasted several hundred million years. Roughly 400 million years after the Big Bang, the universe began to come out of its dark ages. Now, this period in the universe's evolution is called the Age of Reionization. during the reionization phase, hydrogen gas that had been fogging up the universe before had cleared away and expanded, which allowed the universe to become transparent to ultraviolet light for the first time, which is light that's visible to our eyes. And during this time, clumps of gas collapsed enough to form the very first stars and galaxies. Gravity gradually drew matter together to form the first stars and the first galaxies, as the objects were attracted to each other and clumped together. Now, our solar system is estimated to have been born a little after 9 billion years after the Big Bang, which happened 13.8 billion years ago, which would make our solar system about 4.6 billion years old. Now, the universe is continually expanding farther and farther in all directions at a rate known as the Hubble constant. It's expanding in all directions, which means that it's not only expanding horizontally or vertically as you might imagine in like an XY plane, but it means that everything is moving farther away from everything else. It's expanding in all dimensions. So a lot has been discovered and theorized about the creation and evolution of the universe, but there are still so many questions that remain unanswered, and cosmologists continue to research and probe the universe in hopes of better understanding how it all began. Because we have made this theory and we have come up with several ideas, but us humans on Earth and astronomers, we cannot really be sure. This is just our best guess. Now, to review the phases of the formation of the universe, we have the Big Bang, the initial start, which was the appearance of space everywhere in the universe. After that, very shortly after that, was the phase of inflation, which was a burst of expansion, and the universe grew exponentially large and doubled in size at least 90 times in an incredibly short amount of time. Now, after inflation came the phase of recombination, which was when the universe had expanded and cooled enough for for electrons to combine with nuclei to form neutral atoms. Now, after that came the cosmic dark ages, which lasted several 100 million years. And during this time, there were no light-producing structures such as stars and galaxies. They had not existed yet, and the universe was incredibly cold, like thousands of degrees Celsius negative. After that came the phase of reionization, which is when the universe became transparent to UV light, and the very first stars and galaxies began to form. Currently, we are our universe, our galaxy, is after reionization. Reionization was sort of the beginning of the period when galaxies and stars were forming, and now it has been several 100 million years, and we are in the galaxy existence phase. Now this is something really cool that is a once in a lifetime thing that is happening now, which is the comet Neowise. The comet Neowise is passing by planet Earth, and it will be the brightest visible comet since 1997. And in the northern hemisphere, we can see it in our own backyards. If we look to the sky about an hour and a half after sunset, and you can locate the Big Dipper in the sky, the comet Neowise will appear just under the Big Dipper and above the horizon, so in between, and it'll be about as bright as the constellation stars within the Big Dipper. The comet Neowise will be the highest in the sky and brightest on July 23rd, which is when it will be closest to Earth. And the next chance that this comet Neowise will be in our galaxy again will be in 6,800 years. So this is a lifetime, once in a lifetime opportunity. So I suggest that everyone go out all this week, and especially on July 23rd, and see if they can spot this comet in the sky. So that was our completed first lesson about the formation of the universe. It was a little short. Does anyone have any questions? You can put them in the chat box or unmute yourself. And next week, we will be learning about the physical size scale of the Earth compared to the Sun, compared to our Milky Way galaxy and the entire universe. So thank you everyone for coming to the astronomy class. If you have any questions, you can email me or ask them on Google Classroom. And these slides and this presentation will also be available on Google Classroom later. So thank you everyone for coming, and I hope I see you next week. I hope you enjoyed this lesson about the Big Bang.